So now we're going to look at angular velocity and angular acceleration. Just as a couple of definition reminders, velocity was the rate of a position change, and acceleration is the rate of a velocity change. For angular velocity, we want to look at the rate of the angular position. And for angular acceleration, we want to use the angular velocity and see the rate it changes. Now for our symbols, we want to use the Greek symbols for our angular quantities. And this is almost across the board exactly, which means position is going to be the Greek letter theta. Velocity is going to be the Greek letter omega. And acceleration is going to be the Greek letter alpha. So that's angular position, angular velocity, and angular acceleration. A lot of students start calling this a W and just calling this an A, but that's an alpha and that's an omega. Make sure you use the right symbols. Now for our equations, starting with angular velocity. Just like we did with our regular velocities, we recognize that that rate of change is done by our derivative. So this is the derivative with respect to time of the angular position, or d theta dt for short. If I only care about the average, I can use the delta form of this equation. For angular acceleration, we have a very similar equation, except for it's the derivative with respect to time of the angular velocity, or d omega dt for short. And again, our average acceleration can use the deltas. Now in terms of units, my standard unit for angular velocity is going to be radians per second. And my standard for angular acceleration is going to be radians per second squared. And we use the radians as our angular unit here because it's going to be really, really useful in several other equations. We need to have our angles in radians for those equations. So it's a good idea just to get used to working in radians over here. But be aware, particularly with angular velocity, that you might sometimes get a unit of something like revolutions per minute. It's still an angle per time, so it's an allowed unit for angular velocity. Also be aware that they shorten this revolution per minute down to just RPM, revolution per minute. So if you see RPM, or revolutions per minute, you're going to want to convert that into radians per second for most of your calculations. So that's your basic introduction to angular velocity and angular acceleration.